Okay, problem 10.20. Let f be an integrable function from the closed interval -1 to 1, okay, real function. Prove this equality, that the integral between 0 to pi of x phi f composed with the sign is equal to pi over 2 the integral between 0 to pi of f the sign. Okay, and the hint is to do the change of variable y equals pi minus x. Okay, so we have from 0 to pi x f of the sign, right? Now we write y is pi minus x, or in other words x is pi minus y, dx is minus dy. Now when x goes to 0, y goes to pi. When x goes to pi, y goes to 0. This is pi minus y. You have f times the sign, f composed with the sign of pi minus y minus dy, right? So minus goes here, and so we know that we can invert the order of the integral. So this is from 0 to pi minus y, and then we need to know what happens with the sign of pi minus y. Now, using the formula for the sign of the sum, this is the sine of pi times the cosine of y minus the sine of y times the cosine of pi. The sine of pi is 0, so this is 0. The cosine of pi is -1, so this is equal to the sine of y. The sine of y. Okay, so this is f times the sine, composed with the sine of y dy. Okay, let me erase this. And now we have pi, the integral between 0 to pi of f composed with the sine dy, minus the integral between 0 to pi of y, f composed with the sine dy. Okay, now this integral and this integral are the same, so we have that we can pass this summing, so we have 2 times the integral between 0 to pi of x, f composed with the sine dx, equals pi, the integral between 0 to pi of f times the sine dy. Now we divide everything by 2 and we get the desired equality. Okay? Now calculate the integral from 0 to pi x sine of x 1 plus the cosine square, right? Now whenever we have something like this in a math problem, we're meant to use this identity, right? So here we have x, and then f composed with the sine is the sine of x divided by 1 plus the cosine square. Now the cosine square we can rewrite as 1 minus the sine square, right? So this is equal to the sine of x divided by 2 minus the sine squared, right? So f, the original f, is x divided by 2 minus x squared. Okay, so this integral is going to be the same. The integral between 0 to pi of x times the sine of x over 1 plus the cosine squared is equal to pi over 2, the integral between 0 to pi of just the sine of x 1 plus the cosine squared. Now this is 1 over 1 plus the cosine squared times the derivative of the cosine, which is the sine, but this is with a minus, right? So this is minus minus. So we have minus pi over 2 times the arctangent of the cosine from pi to 0. Now minus pi over 2, and then the cosine of pi is -1. The arctangent of -1 is minus pi over 4. And then we have the cosine of 0, 1, the arctangent of 1 is minus pi over 4. So this is minus pi over 2. So this is just pi squared over 4. And that's the value of that integral.